In this video, I will introduce you with new logic family, emitter coupled logic or ECL logic family. The ECL logic circuits have the fastest switching speed among all other logic families. The ECL logic circuits are also known as current mode logic or CML, current mode logic. Why the ECL circuits are called CML? Because for the operation of logic circuits, our ECL logic circuits will use the property of current switching. There we will have a fixed emitter bias current IE, whose value will be nearly equal to 3 milliampere, and this IE will switch its flowing path from one collector terminal to another collector terminals of the transistors depending upon the applied input logic levels. Let me talk about ECL inverter logic circuit. There you will see we will have total two transistors, Q1 and Q2, for the differential amplifier portion of the inverter circuit. In the base terminal of the transistor Q2, we will apply our reference voltage VREF, and at the base terminal of the transistor Q1, we will apply our input voltage or input logic level, when our VI will be equal to minus 1.7 volt, which indicates the logic 0 at the input terminal or the base terminal of the transistor Q1. You will see our IE will flow through the collector terminal of the transistor Q2 for the logic 0. Now if I apply logic 1 at the input terminal, you will see the IE will flow through the collector terminal of the transistor Q1. Thus the emitter bias current IE equal to 3 milliampere switches its flowing path depending upon the input logic levels. As the current IE switches its flowing path, therefore our ECL logic circuit is also known as current mode logic circuit. Now let me talk about the features of ECL logic circuit. These are the features of ECL logic circuit. First one is emitters of BJTs are connected together, hence it is named as emitter coupled logic. When I will show you the operation of ECL logic circuit, there you will see for the differential amplifier portion of the ECL logic circuits, we will have total two transistors Q1 and Q2. The emitter terminal of the transistor Q1 and the emitter terminal of the transistor Q2 will be connected or coupled together, hence it is named as emitter coupled logic. Second one is that transistors never saturate. That means our transistor will operate either in the active region or in the cutoff region. So ECL logic circuits will be classified as non-saturated logic circuit. And in a non-saturated logic circuit, there is no storage time delay. Therefore, in the ECL logic circuits, you will see there will be no storage time delay. Now look here, the transistors are prevented from going to saturation by choosing the logic levels close to one another. Here you will see for logic 1, we will apply minus 0.8 volt, and for logic 0 we will apply minus 1.7 volt. See, the separation between two logic levels is only 0.8 volt. As the logic voltage levels are very close, our transistor will not be in saturation. Third point, the logic levels are normally minus 0.8 volt for logic 1 and minus 1.70 volt for logic 0. Okay, Fourth point is minimum propagation delay. So the speed is very high. It has the fastest switching speed among other logic families. Propagation delay is around 1 nanosecond. See, our ECL logic circuits will be non-saturated logic circuits. As in non-saturated logic circuits, there will be no storage delay time. Therefore, the operating speed of the ECL logic circuits will be very high. Therefore, we will get a very small propagation delay, and you will see the propagation delay is only 1 nanosecond, which is the smallest in any logic circuit. Number 5, due to low output impedance, fan out is large. Fan out of ECL will be around 25. While I will show you the ECL logic circuit, you will see in the output side we will use emitter follower circuit. And in case of emitter follower circuit, it provides very low output impedance, usually in the range of 5 to 10 ohm. As the output impedance will be low, so fan out will be large, and fan out is 25. That means our ECL logic circuit can drive total 25 similar ECL logic gates. Number 6, ECL logic circuits produces an output and its complement. This eliminates the need of inverters. In case of ECL logic circuits, you will see we will have two output terminals. One will give us normal output, another will give us its complement. So in case of ECL logic circuit, we don't need any inverter gate to get the complement of the output. And this is the last one. Current through RE is more or less constant, so no noise spikes will be generated like those produced in TTL totem pole circuit. In case of ECL logic circuit, you will see when we will connect the emitter terminals of the transistor Q1 and Q2, we will connect a emitter bias resistor RE with that emitter terminal, and through the emitter resistor or emitter bias resistor we will get a emitter bias current IE, whose value will be around 3 milliampere. Whatever the logical operation we are doing in the circuit, this IE will always be constant. As IE will be constant, there will be no noise spike from due to the internal circuitry. Okay. Although the ECL logic circuits have the fastest switching speed, it has some disadvantages. First one is that having logic levels close to each other, it has low noise margin around 0.25 volt. So ECL circuits are not suitable for heavy industrial environment. See, to specify logic 1 in an ECL circuit, we will apply minus 0.8 volt, and to specify logic 0 in an ECL logic circuit, we will apply minus 1.7 volt. See, the separation between two voltage levels will be only 0.8 volt. This implies that our logic levels will be very close. Due to this very close voltage levels, you will see the noise margin will be very small. Will be only 0.25 volt. That means our ECL circuits will easily get affected by noise. So we cannot use ECL circuits in heavy industrial environment. So instead of ECL circuit, we will use high threshold logic circuits, which will give better immunity against noise. Second point is that it requires a relatively large silicon area and it has high cost. See, to construct an ECL logic circuit, we have to fabricate several bipolar junction transistors and several resistors. As we have to fabricate the resistors, therefore it will take a large silicon area, and due to this large silicon area we have to spend more money. Third point is that high power dissipation, power drop will be around 40 milliwatt. Fourth point is due to high current there is a problem to dissipate heat due to I square R drop. See, in an ECL circuit our emitter bias current will be equal to around 3 milliampere, and we will use the resistors in the range of either 300 ohm or some kilo ohm. Therefore you will see we will get IE square RE drop, or several I square R drops in the circuit. This indicates that due to this I square R drops we will get heat, which will create a problem in the ECL circuits to dissipate those heats. The last point, the ECL input and output are not electrically compatible for direct connection with any other logic family due to negative voltage and logic levels. Say to specify logic 1 we will apply only 0.8 volt, minus 0.8 volt, and to specify logic 0 we will apply minus 1.7 volt. Usually all other logic families use positive values of voltage to indicate our different logic levels, but here we will use the negative levels to indicate our logic 1 and logic 0. Therefore we cannot connect ECL logic circuits with any other logic circuit. Okay, that's it. Thank you.